This is my third time recording this as I keep going far past 10 minutes, so I'm going to be fairly quick. I'm using IBM Watson's natural language processing service to pre-process instructional handbooks into state-based lessons. So I want to make a custom entity recognizer that can look for tasks, events, and triggers within how-to documents. I'm going to be using IBM Watson's natural language processing as well as natural language toolkit and explore a few other avenues. My data sources were pulled online from WikiHow, Helicopter Handbook, and video game missions. There are definitely a lot more options out there. Here's an example of a text file that contains an instruction set. This is just some instructions on finding a double-bladed lightsaber in Dathomir. In order to train a model, we have to pick out our custom entities, which again are tasks, goals, and events. We need to define what each entity is. This can be determined through patterns and parts of speech in relation to other keywords. So some examples: tasks: make a detour to Dathomir to pick up a major lightsaber upgrade. Goals: find the double-bladed lightsaber in Dathomir. Events: you will face enemies, that kind of thing. So what makes IBM Watson Knowledge Studio so powerful is that it's capable of finding patterns for us, and I'm about to go through the steps of training that model, starting with just the first two and then switching over to Natural Language Toolkit, and then we'll come back to IBM Watson. So IBM Watson allows you to add custom entities and you can give them roles. Then you upload your document set, so all of the training documents I pulled from online, more documentation can be found there. And then we'll take a look at the initial steps and how it differs from IBM's process using Python. So for a natural language toolkit, we pip install natural language toolkit, some other Python libraries for data science, and some tokenizers. We then download Punkt. I'll probably skip through some of this code, but we load a text file and tokenize it. This is a how-to guide on tying your shoes, and we tokenize it into sentences. You can see those here. We then will separate those sentences further into individual words. Here is the individual words. So these are steps that are typically taken in most natural language processing applications, but not in this one, in the thing we're trying to do today. So usually you'd remove stop words, and then you'd also do some stemming to get down to the base root of the words. But in our case, both of those things are important for custom entity recognition. So the parts of speech tagging is the most important aspect, as it allows us to find patterns within the sentences. So we parts of speech tag the how to tie your shoes, and we can see we get nouns and determinants and other parts of speech tagged. Here is a list of those parts of speech and what they stand for. So then, using English, we look into task custom entities within Natural Language Toolkit. So by looking from what I highlighted in IBM Watson, I was able to determine that most tasks start with a verb followed by a determinant or a pronoun, a pronoun. And I then wrote a Python script to pick out all occurrences of that, and you can see that they very closely follow tasks, so take both, tie a, and then to add to that, we finish the rest of the sentence. Its tasks are usually quite long, so we have tie a basic knot, the stops at a period in order to stop its sentences. Would let the laces fall to either side of the shoe, see your hand movement, use your free hand to pull the shoelace through. All of these are examples of tasks, or not all of them, but most are. So then we'll go back to IBM Watson's Knowledge Studio and see how you would do it there. You have your set of documents. From here we have helicopter handbooks, how-to guides, and video game informations like I stated earlier. Here's a list of them within the IBM Watson UI. You then go through each of those text files and highlight and you annotate your tasks, items, goals, events, and here's an example of that here. So you highlight, and then IBM Watson takes into account parts of speech and many other factors to try and build a model around what you're highlighting. You'll have to use the Natural Language Understanding service in conjunction with IBM Watson's Knowledge Studio in order to train and evaluate your model. Once you train and evaluate your model, you are then able to create a version in order to roll back in case things get worse. And then we deploy using the Natural Language Understanding. Once we've deployed, we are then able to install IBM Watson's Python package, and here we have a Python script that will run a URL through our model. And so we can see some examples: task, spawn a BNS, tell us in the comments. This is a caveat of using URLs. You get extra information on the website you don't necessarily want. We can place the nest near water, might not be the best idea. Tasks, and yeah. And then below we have another version where we put the tying your shoes text into the same exact model. And we can see task, tie a basic knot. We saw that in the natural language toolkit model as well. Sorry, that's not a model, but in our natural language toolkit code. And you can look through this in more detail using the link to the notebook. So some other options I looked at was the Stanford Natural Language Processing Group. They have a Java implementation of a named entity recognizer. However, it's only used for people's locations and organizations. You are able to give it your own training data, but I did not see any documentation on custom entities. So in conclusion, IBM Watson makes it much easier to create custom entity detection, especially in a simple way with low to no code. It's got an easy interface and allows you to train and pre-annotate new documents using your existing model, so that there's even less upfront work. All that would be needed then at that point is to check the work of your model, and you can continue to increase the amount of training documents going through it. I will have a list of references at the bottom here.